there's other things that are just as interesting as my field of work too, and I love seeing how much she enjoys learning that. So I'm going to talk about forensic DNA and the Israel police. And I'll introduce you to the two DNA laboratories that are in the police, give you a little bit of a historical perspective since we've been using DNA, and I'll tell you some stories to keep you awake, and we'll look a little bit into the future what we're going to be using. It's a very exciting field. It's been an exciting field from the moment that I started working. The forensic labs are in the Department of Identification and Forensic Science, and we're located in the police headquarters in the northern part of Jerusalem. The goal of the forensic laboratories is to provide scientific evidence towards solving crimes. Now, this is very similar to what you do. It's just that our past is a little less ancient than your past. Every crime that's occurred, it's also in the past, and we're just trying to give evidence to try and solve what's happened. If we had been around in the time of the Bible, to get in the mood of ancient DNA, if we had been around at the time when Joseph's brother had brought his coat to his father Jacob and shown him the blood-stained coat, we could have solved him quite a bit of sorrow and mourning, because we could have told them right away that that wasn't human blood. We have a test to show that whether it's human blood or not, and we could have even shown him that it was a goat, and so he wouldn't have, but we weren't around at the time. So we have a number of roles in our labs. The most important things that we can do to help in investigations is to identify linking perpetrators to crime scenes. If we have a reference sample from someone who's involved, we can do that. We can associate crime scenes. For instance, there was a rash of old people being attacked on their way home after getting money out of the bank, and there was blood left at two scenes of the crime. One was in Jerusalem and one was in Eilat. From being able to link scenes of crimes, we can give information that can help in the investigation. One of our most important roles is to exonerate the innocent. A huge importance in our work is to be able to say, and that's the only time that I can give a 100% answer to any question. If the profile that I have from a scene of a crime does not match the person who I'm comparing it to, then I can give it a 100% result that it's not him. The databases, since they've been up and working here in Israel, it's solved so many crimes, and it's also saved so much investigation time. One of our more satisfying parts of our job is providing investigative leads, and I'll give some examples. And some of the things that we can do to help doesn't necessarily have to be connected to crimes. For instance, disaster victim identification, what's going on now in Nepal to help identify people, missing persons, and paternity tests. Okay, so the first lab where I'm going to talk about is the casework lab. That's where I'm working at this point. I've worked in both labs. This is the process of what we do. Evidence documentation is the first process that we do. We have to mark everything that comes in, and as a matter of fact, it's one of the most satisfying parts of the job, because this is where I build the strategy, how I'm going to attack the case, what I'm going to do. Am I going to be successful, or is the item of evidence going to be able to keep it secret and I won't be able to find? As a matter of fact, if you remember, the O.J. Simpson case fell on problems with evidence documentation. We do preliminary screening and presumptive tests, and then we do DNA extraction, quantitation, capillary electrophoresis, profile analysis, and the expert report for us is our final product, and that's what we go. That's what we give the courts, and it's instead of me going to testify in every court. If that's not enough, my expert report, then I am required also to go to court and testify. I talked about the presumptive tests that we can do. If we need to find what we're looking for first, okay? If it's blood and you can see it, that's great, but sometimes you can't. We're able to find semen stains. We have both chemical and immunological tests, and we can look in the microscope. Fadabus is a chemical test that reacts with the enzyme in amylase, and we can see where saliva has touched our items. These are real items of evidence that have been in the lab. Castlemeyer and Hexagon are also presumptive tests for blood. For those who can't read, this is a real knife from one of our items of evidence. If people who can't read the Hebrew, it says, take care of yourself, Rivka, with a heart. Okay, we can also look for latent blood stains. A lot of times people try and wash the evidence out, and there's a solution that we can use to try and find. For instance, this is a chair from a car where an attempted murder took place, and they washed all the upholstery. But when we put the Blue Star solution on and turned off the lights, we were able to see a fluorescence, and then we were able to take and cut from that area. This is a story of a family that was massacred in their home. The man on the top, he was a boss of someone, and he had a very disgruntled worker who went and murdered his wife, 2 children, and the grandmother in the house, called him, said, come home. When he came home, he murdered him too. And then he set the whole house on fire. He took off his clothes and set the whole house on fire. We didn't, as you can imagine, he took off his shirt, threw it in the house. We didn't want to find the blood of the people. We knew who was murdered. We wanted to find the DNA of the person who had worn the shirt. So we went the opposite direction with our latent solution, and we sprayed it to see what didn't fluoresce. And where it didn't fluoresce, that was where they got the profile from the person who wore the shirt. This is just an example of a few of the unusual evidence. We get some very bizarre things by us. When people are stalking out or casing a joint, sometimes they'll eat seeds and throw them down. Here's a yarmulke, part of a disguise. This is part of a body bomb. It's very hard to work with tape with gloves. So tape is a great source for us to get DNA because the epithelial cells stick on the tape all over. These are just some things from a bomb, a mask, and I don't know if you can tell, this is a cookie. They get very hungry, but I don't understand why they leave half of it there. Why don't they just eat the whole thing? Okay, this is a case, we were talking about unusual evidence. This is one of our first cases, and it was a sexual assault case in Tel Aviv. Somebody came in to a woman's house with a huge block of cement, and while she was sleeping, knocked her over the head and tried to attack her and sexually assault her. He wasn't able to sexually assault her, but he beat her up badly, and she fought with him until she lost consciousness. And when she fought with him, she knocked his glasses off, and he left the scene of the crime. Oh, I didn't have the glasses, but anyway. So what I got to our lab for the items of evidence was her bedding, and I tried to find semen on it. And when I opened up her bedding, I found a lollipop stuck to the sheets. And I got the glasses, and I got a sexual assault kit to see if we could find any semen. I called the detectives, and I said, can you guys find out if the lollipop belonged to her or if it was brought in by the perpetrator, because that's kind of weird. And they said, no, it didn't belong to her. She didn't go to sleep eating a lollipop. And so from the stick of the lollipop, I was able to get a mixture of her blood. I saw her blood. I saw blood on it. A mixture of 2 people. If I took her out, I was able to get a profile that matched the profile from the glasses also. Now, what happened was they did not have a suspect. Okay, so they took these glasses frames and they went to all these opticians in Tel Aviv until they found an optician, and it took for the longest time. They found somebody who said, oh, I sold those glasses to someone, and as a matter of fact, he came in last week and he said he lost his glasses at the beach and he bought another pair. So he gave the investigators a name, and when they put the name into the computer, they saw that he had a previous record, and he had been stopped for pickpocketing a couple of weeks earlier, and this was his booking picture. And in the booking picture, he was wearing similar glasses to what was found at the scene of the crime. Now, they asked him to give a DNA sample, and he knew that he hadn't ejaculated, and so he said, okay, I'll give a DNA sample. I didn't do it. And, of course, it matched the lollipop stick. What's very interesting here is this was a collaboration. You spoke about collaborations. This was a collaboration with a bunch of different labs. The Toolmarks lab got the booking picture, and they blew up the picture life side, and they did a physical match from the glasses that were found at the scene of the crime. And as a matter of fact, he was a home improvement guy, and there were little nicks on there and little flecks of paint, and that was also used as evidence against him. Okay, this was just the lollipop profile, her when we took it out, and him, which matched. Now this was when we were only doing 3 different markers, or 4 different markers, but it gave a very proper result. This story is very important because today this wouldn't have happened and wouldn't have been a big deal at all. With the database in place and working very well, right away when I had the profile, we would have seen that he should have been in the database because he had a previous record, and they wouldn't have had to do all the footwork trying to find out who the frames had belonged to. There would have been an immediate database. Taking you into the database then, the database, in 2005, the Knesset passed legislation that permitted the Israel police to set up the DNA database. 2007, it started working. Okay? There's just changes all the time that we can make. And the profiles, that's different from country to country. The profiles that we're allowed to put into the database are suspects, accused, convicted offenders. In a lot of places, it's only convicted offenders, so we have more in the database than in other countries. And the crime scene profiles from all of our casework laboratory. We sample from the inside of the cheek and put it on these special FTA cards that archive it. And today, there's more than 300,000 reference samples, almost 20,000 crime scene profiles, and we have more than 10,000 hits. Okay, our first high-profile database match was also, this was a murder that occurred in 2006. If you remember, I said it started in 2007, the database was up and running, but there weren't a lot of people at that time anyway. But in 2006, a very well-known lawyer was in her home, a single mother, and somebody knocked on her door at about 10 o'clock at night. And when she opened the door, he demanded money, and she started screaming, and he got scared, and he stabbed her a number of times and ran away. And from her yelling, her children came downstairs, and the only thing she was able to tell them before she died was he was very young. And then she died, and they had nobody. This was he threw away, when he ran away, the knife that was used and the gloves. There was blood on the knife that matched the victim, and a male profile from the knife handle, and from the gloves, the same male profile. And we put that into the database, but nobody came up. Now, because it was so early at the time, and there weren't people in the database, they sampled over 500 people that had previous records to see for property crimes in that area, and of course nobody matched. And this also wouldn't happen at this time because you don't have to go back and ask people for more samples, because once they're in the database, they're in the database, and nobody's going to bother them again, and they're not going to have to explain to their mother or their girlfriend or their wife, I didn't do anything this time, they want to check again. Okay, 2 years later, a 17-year-old boy was arrested and questioned for driving a stolen motorcycle, and his DNA sample matched that of Anat Flinner. That was pretty amazing. He was 15 years old at the time. Okay, now I'll just give you a little bit of a historical perspective. When I started in 1992, we were still doing proteins, and we went then to RFLPs and to mini satellites, and then we started working with STRs, and STRs is what we're working with now. I'm very grateful that I've been able to do all of these different methods. It just took so much time. When we started, it would take months until we could give a little bit of an answer, and the statistics weren't they were much better than the protein statistics, but we were really excited with everything we were doing, but it just took so much time. In the beginning, we needed a huge amount of biological sample to be able to get enough DNA to work with. The button is only for reference to let you see how, And then we needed littler and littler. And today, I don't even need to see what I'm working on. Touch DNA is so sensitive at this point. With our methods are so sensitive, and we need so very little DNA that I don't even need to see. Anything that's been touched, I can try and get a DNA profile from. As you know, we're working on short tandem repeats, repeating core sequences or units of 2 to 7 bases. Most of the STRs that we're using, they're repeats of 4 base pairs. And all of the methods that we've used have all worked on the same principle, and that principle is polymorphic markers that are passed on genetically. Okay, this is the typing process just that I told you before. From the technology point of view, we use at this point, we do DNA extraction in a robot. We do DNA quantitation, which also at this point can tell us whether it's male DNA or not, which saves us a lot of time. Because, for instance, if I am trying to find the DNA of a perpetrator from a sexual assault case and there is no male DNA, I don't have to continue on with my testing. Okay? We use real-time PCR for the quantitation. PCR, we're using a multiplex kit. I'll explain in a second. Doing capillary electrophoresis, and we're using GeneMapper software. If I put together all the time that it takes, not including the documentation process that I spoke about in the beginning, this takes up to like 10 to 12 hours, okay? Just if I work nonstop just to give the investigators an answer, okay? Now, in these new generation kits that we're working with, we have now multiplex kits, okay? In the beginning, I worked, that first story that I told you about had only 4 markers. Now, today I'm working with 15 markers, and in one shot, I get all of my answers. I get gender identification. They're very robust. You guys need to know, you guys also have lots of samples that are very difficult to work with, degraded, inhibitors and stuff like that. These kits, the chemistry has gotten so great that I can get a result from very difficult samples. Okay? This is the kits that we use, and in our hands it works wonderfully. There are bigger kits. There are more, I could give a profile with more information, but this is the one that we're using, and it worked very well. And the statistics of the most common profile exceeds the amount of people that are on Earth. Okay? This is just one more story, a quick story about, do I have time? Yes? Okay. A quick story, also keeping in the ancient DNA. And this was to stress never to underestimate luck in solving crimes. A lot of our work is very routine, but the satisfaction I get is when I can help in the crime-solving process. Now, this story also, it's a story of 3 brothers, Abraham, Isaac, and Jacob. This story today, it wouldn't have been at all, it wouldn't have happened at all. It wouldn't have been a story that would have been worth telling. There was a little girl, a little 5-year-old girl who was sexually assaulted in a stairwell on her way home. And the only thing that she could tell her investigators was that the guy was wearing blue flip-flops, beach sandals. And they had no suspect whatsoever. I had a pair of underwear with a semen stain on it, and that was all I had. Through intelligence, they found a deranged guy that lived in the neighborhood who, he said, maybe I did it, maybe I didn't. And when they went to his house, his brother, a soldier, did have blue flip-flops. So they took the guy and they started investigating him. And at that time, we were doing 9 STRs, which is very good, differentiating and discriminating. But we were doing it in 3 triplexes, okay? So here was where my luck played. The first triplex that I did with THO, TPOX, and CSF, he matched completely Isaac, the suspect, the deranged man. And so the investigators were all excited, and they said, it's got to be him. I said, wait, I have some more tests to do. In the second one I did, he didn't match at one of the loci. And so I knew it wasn't him, okay? But there was such a similarity here that, and in the other one, and then in the next one, he also didn't match. But there was such a similarity that I went to our statistician, Professor Uzimoto, our colleague here, and I said, that works with us, and I said, can you tell me how? He did a likelihood ratio, and he said, look, it's probably a brother. It's so similar. So I went and I asked the investigators to please bring me DNA from the 2 brothers. One had an alibi and lived in Ashkelon, and he fell right away. And the second brother, they didn't want to get him because they said, look, you know, he's been so supportive of his brother. We've put the family through so much, you know, if it's not him, it's not him. It took me the longest time to get them to bring me a sample from the really wonderful brother that accompanied him everywhere, the brother Jacob, I'm sorry. And as you can see, he was the one that did it and was going to let his brother take the fall. Now, why do I say about luck? If this had been today, right away with my first multiplex kit, it would have fallen off, okay? I was going to say about the adventitious matches, it's important to have more markers. Why? Because we had 2 siblings that was in the database that differentiated, they were different from each other at only 1 allele and 1 locus. If we had an item of evidence that did not have that locus that amplified, I could have wrongly said the other brother might have been the one that did it. Okay? When we add more loci, you can see the more loci that you add, the more it differentiates. Okay? Even if they're interbred brothers and cousins and everything like that. We have difficult samples too. This was just one example of condoms that when I tried to get it using one of the older kits, one of the less robust kits, I could not get a profile. When we did it with the new ones, we got a perfect profile. And I'm sure that you guys are seeing in your hands these new chemistry multiplex kits are working very well. Sometimes it's even too sensitive. We get so much information we can't do anything with it. Okay? I won't talk about that. One of the cases that we had here in disaster identification, there was a fire that we helped identify 44 people that were burned alive in that bus on the way up to evacuate a prison. Thank you. Okay, so what's in the future? Because that's what I was asked here. Rapid DNA, phenotype prediction, tissue identification, which is very, very important for the investigation. Okay, when I can see what I'm working on, that's great. But sometimes, like in incest cases, where a father's DNA is permitted to be on the child's pajamas, if I know that it's from semen, that's very important in the investigation. Epigenetics, it's going to be a way that we're going to be able to tell apart identical twins. The methylation stuff that's going on is very exciting. And the next generation sequencing, which you're also very familiar with already. So I talked about the process that takes 10 to 12 hours. With this new rapid DNA that's coming out, we have sample in and profile out within 90 minutes. And the person that has to work this machine does not have to be a biologist. He does not need special training. It's called turnkey technology. You just put the thing in, you get it out. And as a matter of fact, these are the things you'll be able to use it for that'll be very effective. Arizona has already started uploading DNA samples using this technology. Okay, forensic DNA phenotyping, which you guys have been using, and it's going to be becoming part of our forensic testing and helping provide investigative leads. My friend Wojciech Branicki from Krakow, who has been a big part of this, says anybody who's interested, he'd love to work on some of the bones that are here in Israel, so if anybody's interested. They'll be doing 3D facial shapes from DNA. Pretty amazing. Just the people on the top, they're not real people that were investigations. This is all in still being tested. Okay? There's a case from 2011 in South Carolina. They do not have a suspect yet. He's not in the database. They have his DNA, and they have been able to make a snapshot, or what they call what do you call it in English? Clusteron. A booking. They're trying like a mug shot, but this is a genetic mug shot. They do not know who this person is, and they're trying to find somebody. Okay, the next generation sequencing for forensics. These are the two companies that already have stuff going for us. Well, in one reaction, with one sample of DNA, we'll be able to get all of these markers and information at one shot. Okay, these are the kits that are already available for forensic, according to the things that you require. All the STRs and the SNPs, according to the things that you want for your testing. Okay? The challenges will be for us, of course, are the bioinformatics, the software that's going to have to be developed. At this point, if I do a test, I have to report it in my expert report. I'm not going to be able to report all this information that comes out. I'm going to have to pick and choose, cherry pick what I want and put it in to my expert report, which is going to have a lot of, it goes into the next thing, the database considerations. Not all that stuff's going to be able to be put on the database, okay? There's real legislation problems that are going to come into play here to decide what's going to go in. Okay, final thoughts. And, oh, it's okay. The methods that we're using today, the STRs, and the capillary electrophoresis, it's super robust. The majority of all of our information that is on the database, that's what we're using, and it's working wonderfully. The database is all over the world for sharing of information. We're not going to be able to just go start on SNPs and stuff like that. The STRs is what we have to use, and it's on the database. But change is coming, and it's not only coming, it's here, the rapid DNA and the next generation sequencing. And it's pretty amazing. And the most important, I think the most effective use of the next generation sequencing that we're going to see coming into play more and more is providing these investigative leads in cases where there is no suspect at all. That you can give some thing to give them an idea how they can go and try and find somebody. Okay, thank you very much for your attention.
Do you have any questions?
How's DNA evidence presented in court in Israel? Do you just use match probabilities? Can you present Bayesian probabilities?
We use match probabilities, and in mixtures and stuff like that, we use likelihood ratios. And
so the likelihood ratio itself can be presented to the jury?
It's written, likelihood ratios we use. As a matter of fact, I don't use the likelihood ratios. If I have a mixture that's more difficult, then I have a very basic knowledge of statistics. Okay, so I give a match probability in my expert report, and if there's something more complex, then we have our statistician also add his expert report, and then he can go into likelihood ratios. How much more is it expected that it comes from these two people to make up that mixture, or other people?
So in the US you have different databases for different segments of the population that you can use for calculating match probabilities. Do you have that here too?
Well, we have
African American.
Okay, so we have our statistics was built originally from, first of all, we use statistics that is accepted within the forensic community as a basis or a base, and before we start using each of our new kits, we do our own statistical analysis for, say, 100 Jewish people, 100 Arab people, different ethnic groups, Ethiopians, and stuff like that. And then Professor Motro builds the which I can't really explain very well. You know it all better than me, but that's how we base our statistical analysis.
Other
Yes.
questions? Yeah, that.
Who was held in the database in Israel? Suspects or?
That was one of the slides. It's suspects, but not on every single crime. The major crimes, okay, there's some things like white collar crimes is not in there, okay, but attacking a police officer is not in there. It's a shame that not everything's in, and at the bottom when I said in 2011 there were some changes made to the legislation to enlarge the amount of people that we can bring in. So it's suspects, convicted offenders, and what was it, the third one? The convicts and people that are sitting in jail.
So following up on that one, perhaps, do you have a DNA database also?
Do we have a DNA database? Yes,
Not
we
just the profile database, the DNA database.
We have from every crime scene sample where the profile is meets the criteria. Yes, there's more than 10,000 crime scene profiles in
So
the
virtually
database.
you can upgrade everything to NGS really rapidly, actually, because you will have to rebuild the full database if you.
Well, how can I go back and get the if for instance I used all the DNA up?
Exactly, that's my point.
Yes, so the STRs are here to stay, really, and as a matter of fact, as long as you have that base of like 15 that we're using now, even if we add more and we don't have more DNA to go back and retest samples, at least we'll have quite a nice possibility to do overlapping.
Rasmus, you got a second one.
Yeah, so you alluded a little bit to familial searching. You had a specific case where you did that. But is it legal in Israel to do general familial searching? So your search is, you don't have a
It's not illegal. Let's put it this way. Well, no, it's very important because we just had that very big case where a crime that was unsolved for like 17 years was just, they used familial searching to see if they could find somebody, and they did. And it's not prohibited. It was not addressed in the legislation. I think that they're going to try and make sure that it will be addressed, and because it's an amazing tool. It's an amazing tool. And we've seen, because we did everything in-house, you were talking about Aryeh Voskoboynik. We have a boy in our lab, a gentleman in our lab who set up and built all the matching, he and another man, and because of in the beginning, we didn't have automatic putting into the DNA database the profiles. We had to upload them manually. We put in an opportunity to catch mismatches. Okay, we put in an opportunity to catch 3 mismatches, and what we saw was that occasionally we were finding brothers. Okay, now you have this investigative lead, you have this information, what do you do with it? I don't go to the investigators and say, maybe it's his brother, okay? So it's not prohibited. It wasn't against the law what we did. It may be problematic, and I think it should be addressed so that it's an amazing tool. And in America, forget it, in California, Rock Harmon, and I don't know if you're familiar with it, but they're using it and they're getting more and more hits, and they're worried about the personal rights of people, but we as people that live in and want to be safe, we have personal rights too. So.
But if you're doing that, why don't you get volunteers to just give me a date, all their data?
Because that's not in the legislation either. If it were up to me, I'd have everybody in the database. Okay. Fine, but I mean, why would somebody volunteer to put his DNA in the database? For instance, now we're going over to biometric everything. The question is, what are you going to do with it? The next generation is also very problematic because you're getting into areas of the DNA. All the SDRs that we use, they are not in any coding region. No, they'd give no information. But you're getting into some really heavy-duty stuff that you can give some information about, and to make sure that they don't use it in the wrong way. And volunteers, nobody's going to volunteer to give his.
Well, the uniform was called by his brother. You'll snitch your brothers. Altruistically.
Yeah.
So one last question.
That new technology where you have facial recognition, if I gave you a sample of the bone, Could you show me what the person looked like?
Well, some of the work that was going on, as you can, there were some articles there for hair and eyes, and I don't know about. It's all based on the SNPs and those single nucleotide changes, polymorphisms. Would I be able to? No, we're not using that. But there's somebody in our lab that's doing quite a bit with SNPs, not for phenotype prediction or facial recognition, but for mixture separation and things like that. That's definitely in that direction. I mean, you've been using it to predict what ancient people looked like, you know.
So,
It's things that you guys have done, or we're starting to use in our field. So, yeah.
Doing it in a more sophisticated way, but you'd need some fairly well-preserved DNA.
Well, the DNA that we get, I would say, is much better shaped than the DNA that you guys are using. But, for instance, we have gotten bones that have been at the bottom of the sea and stuff like. We haven't done anything with it for that. We were just trying to get STR information. But, yeah, there are. And as a matter of fact, I saw a poster outside that was forensics with shrunken heads. So, I mean, when we talked about collaboration earlier, there's plenty of stuff that can be done with the forensics and this. It's an interesting field. It's very amazing.
All right, thanks a lot again.